we're going to look at Pythagorean triples. They are special right triangles. And we'll take a look at these today. You remember this one. Of course, the Pythagorean theorem that a squared plus b squared is equal to c squared. Now, Pythagorean triples are pretty nice. They are really described as a triangle, right triangle, and you form a triple when all three sides are whole numbers. So there's no, they come out perfectly. Let's take a look at an example. Let's use this one, and let's say that a is equal to 3, b is equal to 4. We want to know what c is. We apply the Pythagorean theorem. We do our substitution. Take the square root here. And we know that c is 5. So here we have a Pythagorean triple. 3, 4, and 5. So they're all whole numbers, Pythagorean triple. Now what's cute about these, if we take multiples of 3, 4, 5, and I'm just going to write them down here. If I take 6, 8, and 10, multiplying, of course, each by 2, we have another Pythagorean triple. How do we know? Well, let's do a shortcut. We have 6 squared plus 8 squared. And does that equal 10 squared? That's our question. We have 36 plus 64 is 100. Add them together, and indeed, it works. So anytime we multiply 3, 4, and 5 by that, and that's called a scale factor. This was a scale factor of 2. We have a triple. Now, a lot of people know about the 3, 4, 5, but there are other Pythagorean triples of which you should be aware. We saw one once before. There's the 5, the 12, and the 13 Pythagorean triple. If we multiply these out, this is a triple. And we, of course, can have other factors. Let's take a look at a scale factor of 2 for this one. And we would have 10, 24, and 26. There's another one that a little rare, but it is also seen. It is the 7, 24, 25 right triangle. This again is a triple. Now we're going to look at a scale factor of 3 for this one. So we multiply each of the numbers by 3. We have 21, 72, 75. Pythagorean triple. Please, if you're going to figure this one out, use your calculator. These are Pythagorean triples, and they all come out. Now I'm going to give you an opportunity to find a triple on your own. You need to take two numbers, n and m, and we know that n is greater than m. So if I say, okay, let's take n. I'm just going to pick a number. Let's say we're going to call it about 5. And m, we're going to call 2. And we're going to create a Pythagorean triple. We do it in the following way. Our first leg is going to be n squared minus m squared. Our second leg is 2 times m times n. And our last leg will be n squared plus m squared. We'll substitute. Here we have 5 squared minus 4 squared. 25 minus 4 is 21. We have this one. So we have 2 times 5 times, now let me put it in the right order for you. 2 times 2 times 5, which will give us 20. Substitute here, we have 5 squared plus 4 squared. 25 plus, that's 2, and I'm jumping ahead of myself, plus 4, or 29. Those are our 3 legs. Obviously, this one's the hypotenuse. Does this work? Let's find out. So we'll take a squared plus b squared. Is that equal to c squared? So we have 21 squared plus 20 squared equals 29 squared. That's our question. 21 squared is 441, plus 400, which is 20 squared, and this is equal to 800. Let me double check my multiplication. I made an error. 42, there we go. It is 441 and 400. And this indeed is equal to 841. So we do have a Pythagorean triple using these three for our legs. Okay, when you're working with your Pythagorean triples, if you have questions, check with your tutors, and now go to work.